Okay, so this is the least discussed operational pattern that we ever think about, right? The break glass, repair fast, reconcile automation. And the key is that you have to go through all these layers, right? Nowadays, it's not enough to say, I need to go to my infrastructure API, make a change in the console, and we're all happy. It turns out there's a lot of complexity involved when you have more automation around it. And we'll go through that. Let's start with the first phase of this, which is breaking glass. Breaking glass is a term I borrowed, although many other folks will use this similarly. Breaking glass is in case of emergency, right? So if there's an emergency, you break the glass on something and you can pull the handle. And break glass is more common now in systems and infrastructure, partially because we implemented least privilege. And if you're familiar with least privilege, that means that we secured our systems so well that no one can access them. And so the reason why we've secured it so well is that we've done something called infrastructure as code or whatever as code. It doesn't have to just be infrastructure components on the cloud, right? The idea is that if you want to make a change, you commit and you push, and everything else is handled by an automated deploy. This is pretty neat. We're pretty happy with this pattern in some ways. If you're in an organization that's gotten to this point, you probably don't have access to your infrastructure systems anymore, although I won't tell anybody if you do. But if you don't have access to your systems, this is the pattern that you're going to use to make changes. Any change, even if it's instant. But it turns out that, well, we have to fix things. And inevitably, we have this break glass scenario where if you do need to implement a fix, you need to sort of intercept this workflow and you don't get to commit and push anymore. Instead, you intercept and you manually go in to fix something and then you deploy. So breaking glass is more common than you think. And if you're in an organization that didn't commit fully to an as-code approach, you might find yourself doing break glass more often than not. Break glass is the fixing the way you're not supposed to. Everybody doesn't want you to fix it this way, but you are going to have to do it anyway. So there's actually a pattern and a focus and a practice around how you do this properly. Let's take this example. So imagine you have your UI, CLI, someone uses it to provision infrastructure. You've got GitOps running, which is another set of automation that continuously deploys changes to your infrastructure. You've written stuff in infrastructure as code, which also deploys changes to your infrastructure. And in this layer, right, if you're having some issues, you might look at the GitOps layer and say, there's something interesting. It's coming back with some errors, and I don't really know what to think about this. So I'm going to debug further. I'm going to look at my infrastructure as code. Maybe your infrastructure as code is saying, there's another issue, and something's wrong with this database, to take the example we had earlier. And then finally, we reach the this is fine stage, where nothing about the automation will fix it, so now we really have to break glass. And that's where breaking glass becomes a science. It's not about the GitOps. It's not about the infrastructure code layer. It's not about any automation layer you have around it. It is getting to the lowest level interface that you need to get to in order to make changes. So then you ask the question, who can break glass? And there's an interesting story behind this. I was going to have a live demo for this talk, but unfortunately I was locked out of it because the demo had some anomalies. Some anomalous API calls, and thank you, security team, and I do appreciate them a lot. They locked me out of it, which is fine. But it turns out that I had no way of breaking glass because I wasn't really on this list of people allowed to break glass into this locked account, right? So here's where things get a little bit strange and where we don't actually think about this, right? We don't think about access as a life cycle. We think of access as binary. You can have it or you can't have access. But the reality is access is a true life cycle. It's not purely least privilege, right? So we actually have a full life cycle of, do we identify this person as someone who has access or can have access for a certain period of time? Can we grant them access for a certain period of time? Let them fix it, and then we revoke the credentials that they have or the access to the system. So we have to stop thinking about access as binary. Yes, you can have it. No, you can have it. It turns out it's more of a life cycle that you can have access for a certain period of time. And so in my case, right, if I needed to break glass, I should hope, and there is a way to do it, I should hope there's a way for my team to grant me temporary access, hopefully throughout the course of this talk, so that I can access my account again, right? So access as a life cycle becomes an important consideration when you think about breaking glass. And it turns out that the problem is not least privilege. It's not minimizing the amount of access someone has or the type of access. It's about automating ephemeral access. Automating access point in time to give just enough for someone to fix something and to go back and take it away once they're done. Automating ephemeral access is a bit tricky, but here's a workflow that you can use and pretty much solve most of these problems in probably a simple way without as many tools, right? So it's a workflow. First, define a break glass role. This role can have additional or elevated access. It could have admin access if you want. The point is it can have elevated access right to go into your production infrastructure or your production environment to do some debugging. So define that role, keep it in place. The next thing is that in a break glass scenario, when someone needs to debug, add a user to the role. It seems very simplistic, but oddly enough, this is a little bit harder. If you have an identity system in your organization, you might have some issues adding users to a specific role, but this is a temporary grant, right, with elevated access to the role. So you use this workflow during a break glass incident. Finally, when you resolve the incident, you can remove the user from the role. Wow. Yeah. It seems so simple. So let's actually look at this in action, and here we go. One thing that I do get a question on is when you define a break glass role and you go through this workflow, well, how do I signal that the event has happened, right? How do I signal that I need to do break glass? In the more straightforward way, some people do a pull request, right? They do a pull request on a repository that has sort of the rule definitions in it, and they say, give me access, right? And then someone else says, okay, you can have access. They merge the PR, and things are great. In a more dynamic environment, some people use webhooks. So one example is that if you're using Alert Manager or some kind of manager that organizes your alerts, you can fire off a webhook to wherever your automation component is to add the user to the role. And then when it's completed or when the incident resolves, that status changes and a webhook fires to remove the role. So an example of this is that let's say I have a resource here. I'm going to tell you this. This is showing Terraform. Terraform has a lot of different alternatives today, so you can choose which one you want. If you're version 1.5.6 or earlier, that's open source. Right now, though, it's source available for future versions. So I will say this, anything that you see here is going to apply to open source version of Terraform. It's a pattern. And a lot of these features and functionalities will apply across the board. So I just wanted to make that clear. If you're using this code and you run into issues, just let me know. So this is a resource that, let's say, defines AWS SSO admin permissions, right? And this is more common if you need a single sign-on in your organization. Imagine in that break glass scenario, you need elevated access. So this is a permission set that says production or break glass. Once you add a user or a group of people to that break glass policy, what you can see is, all right, let me just apply that, make sure that I grant access to someone. And then when it's done, when someone's finished the incident, I can remove that access, right? If you're using infrastructure as code, keep this in a separate state. You shouldn't be doing this in a large group of, let's say, a huge definition of all your infrastructure resources. So if you have an IAM repository that hosts all of the information about your identity and access management, you probably don't want to be doing it in there. It's not very dynamic. And this is temporary, right? So if you do have that PR, you're going to end up sitting there for 20 minutes waiting for all of the resources. So instead, move it out into separate state and you have a little bit more of a dynamic approach to it. The equivalent, though, is if you decide to do this in like any other workflow that you have, you can switch to use the access management API that you have and delete to the access management API. So if you're using privileged access management tools, there are open source ones available now. You can use an API call on the webhook to actually add a user to a role within your privileged access management. So that's a couple ways that you can do that. And so again, we'll go through some of the examples of ways that people have done this. One of my teammates has done this through, let's say, Alert Manager, where Alert Manager detects a high percent of errors. And once it detects the high percent, it opens up a user and a role with access to production. And then once that is resolved after 1 day, then they close that off. So it's one way that you can think about doing it. If you want to do it also a little bit more on the manual side, or you tie it to your incident resolution system, you can do it when a user opens an incident or an incident ticket. You could give temporary access to some operational team, and then once the user resolves the incident, close that off. There's other mechanisms for you to drive these kinds of the break glass actively. Okay. So let's talk about repairing batch. Repairing batch is a little bit more difficult, and we've dedicated entire talks to the art of incident resolution. This is not a talk about incident resolution. I'm sorry, we can go through it, but in this case, we're going to focus on some patterns for repairing very quickly in this particular context, not necessarily on the end-to-end workflow of resolving an incident. But some of the specific steps that you'll find oftentimes when you have a break glass situation, meaning you have to go in and manually make changes, is self-care. So you pause, assess, record, and identify the end state. It didn't sound as good with the I at the end, so it's easy. But we're going to go through each of these steps, and I'll tell a little bit about how you can use this to repair fast. So let's pause, right? Pause is really important. And I say this because if you have many layers of automation in your system, you have to pause all of them. Do not go and make the break glass changes without pausing all of these automation systems. And I'll explain a little bit of why. So imagine if someone goes into the UI or CLI and decides that they'll make changes on the system while you have broken glass and you've made changes in another console. Who gets priority? Whose changes are made to the system? You don't actually know. So you have to lock the changes on the UI CLI. So if you have, let's say, a development team that has access to make changes in this manner, you may consider locking the UI CLI for a temporary period of time. The next is stopping auto sync if you have a GitOps tool. If you're not familiar with GitOps tools, that's all right. Kubernetes ecosystem has something called operators or controllers. The idea is that controllers continuously run, and what they'll do is try to achieve the declared state in a manifest, in a whatever it might be. Right? So GitOps tools do continuously deploy changes until the state achieves the desired one, right, in version control. So if you're using something like Argo, which is one that I use, it is going to auto sync whatever commits you made into your Kubernetes cluster. That's fine, except if you have auto sync on, and for some reason you do make manual changes, like you go in and you do a kubectl edit or you patch manually, it will be potentially overridden by Argo or by any GitOps tool that you have. So what you have to do is stop auto sync. If you don't stop it, it will get overwritten. And you potentially put your system in a more dangerous situation than you had before. Finally, you stop auto approve on your infrastructure as code. Many infrastructure as code tools have their own cycles or pipelines, right? Other times you can say, I'll just auto approve. The joke is like, you just approve it and it goes through and no one cares what happens, right? And the reality is some people don't like auto approve. They don't like automatically applying changes to their infrastructure. And that's fine too. But if you are automatically applying it, which happens in the case of a GitOps framework sometimes, you will find that you have to stop auto approve, right? A good example of this is that someone had an operator that ran continuously and applied changes using Terraform, which means that every change went through. So if the controller kept applying the changes, anything you did manually would get overwritten once and over and over and over. So stop auto approve. So you want to start from the top and then go toward the middle where your lowest level interface is. And then you want to pause everything. That's the important. Next is assess. Assessment is hard sometimes, but you will have to make assessments during incident resolution no matter what, right? But this is where you start debugging and troubleshooting. Is it a cascading failure from automation? Is it a cascading failure from some other system dependency? There's a couple different places where it can come from. I'm not going to go too far into them, but the thought is that making these assessments helps you understand if you need to be fixing something in automation, or you need to be fixing something as part of the overall system dependencies on the lowest level. Right. Active controllers. This is what I was talking about with Kubernetes and some of the operator controllers that you have. You have active controllers that are still running. Some things you cannot pause, right? So certain controllers you can't just pause in Kubernetes. Other controllers are going to continuously be running outside of Kubernetes or other environments as well. Some folks have like active pieces of automation that always read stuff from service catalog and then apply it to something else, right? And so active controllers are something that you must make assessments about. You have to identify if you can even pause them in the first place. Finally, there's a criticality of resource. If you have a very critical resource, this is something that you should treat a little bit differently than one that you can just recreate and just destroy and recreate, right? So as much as we like to acknowledge that we can create and destroy things really quickly, the reality is that there are some things that we can't destroy, or we need to be really careful about fixing, something like a database or any kind of data organization. All right, so quarantine and fix. This is a pattern that I like to use, especially if there's an opportunity for me to break glass and I need to do this really quickly. Quarantine and fix means quarantining whatever resource is under question, and then fixing it manually and then bringing it back under management and infrastructure code. So when you quarantine, what this looks like is you say, I'm going to remove it from the state of infrastructure as code. I'm not going to let infrastructure as code manage it right now. We're going to go back to it, but I won't do it right now. And so this might be commented out, which everybody laughs. They're like, don't I need to delete the resource? No. Just comment it out. And once you comment it out and you removed it from state and infrastructure as code, this typically means that it's no longer under infrastructure as code management, right? So let's do that, and then we'll break glass. We'll log into the machine, and then once we log into the machine, fix everything, we need to bring it back into infrastructure as code management, right? So once we bring it back in, we say we're going to import. In this case, I'll import it back to the state. On-comment the resource, make sure I'm bringing it back under infrastructure code management, and then I can resolve. And by a final resolve, I need to apply my infrastructure code rule again. The reason being is that we need to make sure all the state is good. If there's no changes, that means we've done the right thing. Nothing has happened to our system. Our resources are going to use this virtual machine as expected, right? And then finally, you can clean up, right? There's a cleanup step to this. So this pattern is, I would say, a little bit more common if you're doing a break glass scenario. It's like a mix between doing something as code and a mix between doing something manually. And the reason why you're often going to mix the two is that it's a little bit easier to repair things in automation first than if you did something break glass, right? And you did that later. So eventually you'll have to bring it back into automation anyway. So if you can do this by semi-manual and semi-automated, then you're probably in reasonable shape. But what if it absolutely can't be fixed, which is also a consideration? This is where immutability becomes quite important. Immutability is the idea that you can create resources with the changes instead of making in-place updates. Immutability is a really powerful principle, but it's really difficult sometimes to implement. And sometimes if you're in an organization that you're not necessarily used to doing creation of new resources, this is really hard to commit to. So only do this if your infrastructure as code is already at a place where you're comfortable with immutability and comfortable with working with the principle. That's my general stance on it. So there's an idea of painting resources, and this takes advantage of the principle of immutability. So imagine your virtual machine failed, so you're going to break glass in there, and the manual fix is not possible, right? You've just tried everything, you can't do anything, it's just completely gone. You can't actually take it and fix it. So what you'll do is you'll paint what is called taint in Terraform. And tainting means fixing it as code. That means telling the state that it must be destroyed and recreated. Very good. So once that you taint that resource, it means that it is going to be fully replaced. If you're doing this in a GitOps tool and you're familiar with some of the GitOps tools out there, there's a sync option that's often available to you that you can do a prune or a full replace. So if you do something like a kubectl replace, or not replace, if you do a kubectl replace, this means it will delete the resource and recreate it. So that's the equivalent of the taint, so to speak, tainting resource function in a kind of GitOps framework, which is fine. But the idea is sometimes you just have to destroy it and recreate it. So then you'll resolve it, use Terraform apply, right, to make sure that you reconcile everything back into state, and then you'll test all your dependencies and make sure that it works. Now, because you created a new resource, this is oftentimes really difficult to do. So make sure that other systems that depend on this resource are still good and still able to run against it. So the functionally makes it up. Blue-green. This is less dangerous. If you have a resource that's not high on the criticality factor, and you're pretty much okay with destroying and recreating it, do the other approach, which is to completely replace it. But there are some resources where risk is an issue. There's a risk of replacing it, so you want to do something like blue-green. So imagine your database migration failed. let's say you try to log into a machine, the database can't be restored, nothing is happening, manual fix is failing, your data and your secondary things corrupting your primary, everything is going horribly awry. And so now you just have this option of blowing everything away and creating a new environment, but you can't blow everything away yet, right? You ideally want to stand up both environments at the same time, because maybe even running a semi-working environment is still a little bit better than not running any environment at all, which sometimes happens. So what you'll do is that you'll create a second instance of your database, and then you'll take this last snapshot, restore it into your new database, and then you'll switch the application to the new database, and then you'll take away the old one. The overly simplified workflow. But the idea is that you don't want to take away the resource until you've verified that the application is successfully running against the new database and some of your data has been properly restored. There's a lot of complexity to this that I won't go into. But the thought is that sometimes if you have a very sensitive resource or a resource that is incredibly important and very critical to the running of your system, you'll want to do blue-green. You won't want to do destroy and then create. So both approaches use the principle of immutability, and that's what you end up having to result to now. It's a lot faster to create new resources with the changes than it sometimes is to sit there and try to fix something that is already broken. Okay, so record. Record's short, but you can record in a couple different ways. Ideally, you can record as code. You could say for endpoints, you get really fancy. And if you have session recording, you can actually record the session of you on the machine during the break glass incident, and then export that out, and then use it to reconstruct automation later. The point is, you need a set of steps to understand what you've done to fix something, right? It's very easy to be like, oh, I'll fix it. But then sometimes after the fact, you'll forget how you fixed it, which I do that a lot. So I have to record that. So session recording is one way that you can try to do it. And terminal history is also the straightforward way to do it, although it's not terribly reliable, because if you try to export your history and save it, there's some steps that are out of order. And finally, for resources, if you do manual modification in your infrastructure API, make a document of what resources you modified and how you modified them. There is not really a great way to record how you made changes in the UI unless you ask your security team for audit logs on how you made changes in the UI for most of these platforms. So for resources that are in a UI specifically, make some manual modifications and record how you made them. Okay, end state. Identify the final state of all resources. That's the end of how you break glass, right, and then repair fast. Because if you don't know the final state and where everything is, what do you do next, right? You actually can't do the next step, which is reconcile, obviously. Finally, clean up any blue-green deployments. It's easy to say, I'll just leave it there and I won't touch it again, but you will never, ever go back to it. You might as well clean it up now. I think the number of times that I've accidentally left something in there is very common. So just clean it up when you have the opportunity. And finally, we get to our last phase, which is reconciling automation. Reconciling automation is interesting because when you broke glass and you decided to repair it, you introduced drift. And whenever I say drift, everybody cringes. They're like, no, we didn't want drift. We wanted the difference between our expected and actual environment to be the same. We don't want drift, right? But drift is actually a useful signal, just like most things. Every positive has a negative and every negative is a positive. And drift actually has a benefit in this situation. Drift signals to you that you have one last step left, and that's to reconcile your automation. So when we think about drift, what happens is that imagine that I had that database and I said I wanted to upgrade it, right? And it went horribly awry. So I had to go in and manually upgrade it by hand. Interesting enough, in most managed databases, you have the option of allowing a major upgrade manually or allowing it in automated form. I chose manual perhaps. So I made a manual upgrade of this database, and the manual upgrade caused the actual state to have a different version than the expected code. So, for example, I have an engine version of 13, Postgres version 13 in code, but my actual is 14 because I went into the UI and set up. This is a signal that I need to go back and reconcile my automation. So the reason why we reconcile, or the reason why we consider the signal, is that drift affects future automation, and this is why everybody considers it to be very dangerous. Drift effectively causes unintentional consequences to further changes. So, for example, if I am examining my code, I expect it to be reflected in state. Things are great. The minute I break glass, though, and I make a manual change, this introduces drift, which means that now my state has diverged. It's like the multiverse, right? So what I expected to be in actually reality is not the reality. Instead, I've diverged into a new branch of state, and drift has introduced that, right? And so now every time I make a subsequent commit, my expected is not what I expect. And that's where things also break again. So then you get these really strange change failures where someone forgot to reconcile automation, they forgot to address the drift that's happening in the system, and now they make a secondary change, and then everything goes back to everything failed. That's why, as a general rule, drift is still, it's actually a positive signal for you to go back and fix your automation. So let's actually look at this from an automation standpoint. If we were to go through the layers, if you were to go through for infrastructure as code layer, you would refresh, right? There's an interesting command called refresh only in Terraform. And most tools, I think, have a refresh only approach, where if you refresh, it will actually take information from actual state and then reconcile it back into your reflected state, right? So there's a refresh, right? And then you're going to start sync. Usually, the Kubernetes controllers or operators or anything in this ecosystem, they're pretty good at synchronizing back to the active state, right? So if there's an active state, they're usually going to reflect that in their own state. And in that case, you might have to bring it back to version control. So there's a couple of pieces of this workflow that might be missing here, but just consider the fact that you need to take some of the changes that you've made, put it back into version control, and the minute you start sync again, things are going to go back. And then finally, you can unlock your UI and CLI and allow changes. The reason why this works is the principle of idempotency. So idempotency is the thought that anytime you run the automation, it should achieve the same result. And this is important to consider. If your automation does not adhere to this principle, you cannot do this. You cannot reconcile automation in this manner. What you'll have to do instead is update the automation to handle some of the edge case of you making manual changes. So most systems now do have this approach where if you apply these changes repeatedly, nothing will happen, right? As long as you put it in version control and those changes are going to be applied and that's your desired state, most automation will do that now. Most open source tools that have automation in this space will do it as well. If you wrote your own and it doesn't adhere to this principle or you haven't fully tested it, be very careful. Don't expect that if you immediately turn on the sync again, it will perfectly work. This happened a couple times to me whenever I worked on network switches. They don't have idempotency built by default, so I would have to go and I would have to test to make sure that anytime I reapply the change, I was going to disrupt something. All right, so I guess I could go through this quickly. But the thought is that, hey, you have... Oh, okay. Well, the thought is that let's say you have a GitOps tool, right? And you do want to make these upgrades. This is Argo. You do want to make these upgrades. You'll notice that I've auto sync disabled, so it's not synchronizing. And if I actually go in and I make the change and I make the upgrade, I'm going to go in and use version control to initially make that upgrade. So things are fine in this regard. I'm not going to go through too quickly, or too slowly through this. But as I make the upgrade, what you'll notice is that a lot of things are turned off, and I'm manually going in and I need to manually make changes. So as I make changes through version control, of course, I have a very descriptive commit telling that I have to go to 14.9 for my database. And the minute it says out of sync, you'll notice that nothing is getting applied. It just tells me that it's out of sync. This means that I've broken the glass, I've stopped, and I've paused everything, and now I'm going to go through, unfortunately, 4 layers of automation to go and resynchronize everything and make sure that I do this upgrade properly. So I cannot see the bottom scroll bar, so let's just go through this. But toward the end of it, you'll notice that there is I'll post the video up, but also there is a demo, an actual demo repository. But basically, you sequence each sync so that it's not syncing. And then once you go and you make a manual change, you bring it back into version control, and then you're synchronized. So very much a different approach. So let's go through what we learned. The first is breaking glass. Breaking glass goes through and it takes away all of the other automation layers, right? It means that you have temporary access to go into your infrastructure API or whatever API. It doesn't just have to be for infrastructure. You go in and you manually make changes as needed. And that's fine. But once that incident is resolved, or once that's over, and once you've finished repairing, you'll go in and then you'll go back and fix everything else, right? You go back and you'll turn everything back on, and that's where you start to reconcile all your automation. You go back. And this cycle is something that seems so simple, right? If you're doing something with infrastructure as code, you do something in version control, the natural response is to say, I'm going to do everything through version control and go through this process, right, of synchronizing everything and try to prioritize any changes. But the reality is we don't do it that way. And the result is that we get these really interesting mixed environments where we do things as code, but we also do things manually. And whether your environment is purely as code, you've gone the pure practice route of like, I've done infrastructure as code, no one has access to production and otherwise, or you're somewhere in the middle, the reality is a lot of these patterns still apply. Anytime you break glass, you get temporary access to a system. When you repair it, right, you turn every bit of automation off so that you don't have any conflicts when you come back and you reconcile the automation. So that, if you have any questions, I'll take them off stage because there's no microphone to run around on the floor, so I can't repeat the questions. But if you have questions, I'll be off stage. And if you have any other, concerns, thoughts, feel free to go to this link. There is a demo repository available, and I'll be sure to also post the demo video, which did not work because I don't know, of live demos versus video. I thought the video would work. And yeah, always reach out if you have questions.